Keep going with this one, so we're going to do G now. So this should be much easier now. And all I'm doing is I'm doing different order of operations. So I'm just making the question bigger. So here I have cos 30 plus tan 30 sine 45. So this operation between them is multiply. That makes sense, right? So if I put the two beside each other, it means multiply. If I put a plus, it's obviously plus, right? That should be obvious, yes? Right? 30 and 45. But if they're beside each other, I'm meaning multiply. Here, if they're above each other, it's division, right? So this will be division here. That means divide. Okay? And so now we know squaring, we know multiplying, we know addition. This will just be addition like normal. So now we can do all of order of operations. So all order of operations is fair game now, so I can ask you anything. So let's start with the first one, cos of 30. I already have the special triangles drawn up here. So I usually draw it once on a test, and then that way I don't have to do it again. So cos of 30, there's nothing squared. So cos of 30 is over here, and we go 30, and cos is going to be adjacent over hypotenuse, right? SOHCAHTOA. So if you want to write that again, SOHCAHTOA. You can write it wherever you want. It's your brain thinking. And then I'm going to go, cos is adjacent, right? So root 3, stop me if I'm wrong, root 3 over 2, plus, and then tan of 30, so still sitting here, TOA, 1 over root 3. No, 1 over root 3. Oh, did you square them all automatically? Yes, okay, that's why I do this one. After I do the squaring, people go, yeah, start squaring everything. So that's why I'm showing you. This one's not squared, this one's not squared, that one's not, then I'll do a squared one again. So don't automatically square everything. It's nice to square it because it gets rid of the roots, but I'm not squaring everything. So not squared, not squared. Sine of 45 is 1 over root 2, right? So you go 1 over root 2. Okay, before you rationalize, simplify before you rationalize. So I'm going to simplify and then I'll rationalize in a bit. If you rationalize too fast, you're going to have to rationalize more often. So simplify first, then rationalize. So simplify, I'm going to write that down. Simplify, then rationalize. And you might have to rationalize, simplify again, but don't rationalize right away. Because look, I don't want to rationalize twice because I'm going to put them together. So watch this. I'm going to put them together. Numerator times numerator, denominator times denominator. So now we're back to radicals. So this is really just a radical question, right, from chapter 2. So it's important. So 1 times 1 will be up here. And then root 3 times root 2. What's root 3 times root 2? 3 times root 2 is root 6, right? So back to using radicals. We have to know root times a root. Do that. Now I can't simplify anymore because they're not lowest. Now I'll do rationalizing because I want to do lowest common denominator. So now I'll do this, okay? And then I'll do lowest common denominator. This is a long question. Oh, this is the section where I should bring one of those other calculators. If you use the natural calculator, you plug in this, it gives you the full answer rationalized. You don't have to do anything, which is why we said it's not fair if people have it. And that's why the university started saying, no, you may not have that, because it takes a question that might be worth 4 marks and you've got the answer, right? Or 5 marks, who knows? Okay, so that's why. So we want to do this. Root 3 over 2. 1 times root 6 is root 6. Root 6 times root 6 is just 6. Are we done? No. Now we have to do lowest common denominator. So lowest common denominator, right? So that fraction stuff from before, I'm going to multiply this by 3, then this by 3 to get 6. Okay, we're not done. So this, what's 3 times root 3? How much?
3?
No. 3 whole number times whole number, root times root.
Oh, 3 and root 3.
Yeah, so 3 root 3. Leave the plus root 6, and you can put them all over the same denominator. Can I go any further? How come? How come I cannot?
Because you can't add that.
Yeah. not like radicals. That's a root 3, that's a root 6. You cannot add them, they're not like terms. That's like an x and a y. That's like 3x plus y. You can't add those together. You stop here. You have to know, so we're back to radicals. So if you need to review a bit of the radical section, I think it's chapter 3, 2, 3. I don't know. Go back and look. If you need to review a bit of radicals, you have to know how to do this because the rest of it is radical work. Okay, try it again. So any order of operation works now. So for this one, cos squared 60. This one's squared. So I'm going to do cos squared 60. You can rewrite it if you want. Do you want me to rewrite it? Do you like it when I write it with the big bracket? Or no? Yes, no? Okay, I'm going to do it just so you can see it. So cos 60 and then squared. So if you want to, you can rewrite it like that, but you don't have to, right? I'm going to write it sideways because I don't like it above each other. So divided by 2 sine 45. You don't have to write it sideways, but if it helps you, remember I said you could, right? And you can say this divided by this, and I'm going to put that in brackets. So I usually put the numerator and the denominator in brackets so I can separate them out. I'm going to do this part here first. So cos of 60 is, going back here, sitting on this one, adjacent hypotenuse, so 1/2. Did you even touch your calculator once? No. We don't even need the calculator, right? So see how exact this is? Squared. Yeah, I know, it gives you the bad decimals, so you don't want to touch it. So there, what squared? Divided by, not squared. So square the top, don't square the bottom, don't square everything. And then we've got 2 sine 45. So 2 sine 45 is 2 times, 1 over root 2. I'm going to still finish all of this, so I like to finish all of the numerator, all the denominator, and then I'll divide it after. How do I finish this, though? What do I mean by finish? How do I do this? I have a 2 times that. 2 over root 2. So what you're doing is you're picturing that this is over 1. Whenever I add a whole number in fractions, I put it over 1. So top times top, bottom times bottom. Numerator times numerator, denominator times denominator. Okay, keep going. So the trig part is done. Like you finished all the trig already, first step. So now you want to do the fraction. So 1/2 squared is 1/4 divided by, and it's 2 root 2. Keep going, we're not done. And right, the trig part is done. Now it's just radical work. So we're going to go 1/4 times, and then flip it. Do you remember division becomes multiplication? Is that part okay? So you see how I didn't rationalize that? Because I'm not done yet. If you rationalize it, you double your work. Because people go, I rationalize it, but then you flipped it. So keep going and then rationalize it when you can't do anything else. Then we're going to go here. Top times top, numerator times numerator. It'll be root 2. 4 times 2, 8. That's my perfect answer. Exactly exact. Okay. How many more pages we got? One more page? No, next page. All right, then the last little bit is a bit of a definition. Yes? Really fast. Okay? Okay, so here, just a couple definitions, right? Really quick, we're almost done here. X, Y plane is divided into 4 quadrants. 4 quadrants. You have to know the numbers. This is just a definition, so this last bit here is quick. 4 quadrants. We number it 1, 2, 3, 4. That is just kind of a standard numbering that we gave. The mathematicians decided on. So sometimes they'll say, oh, the graph started in quadrant 1 and went to quadrant 2. So you just have to know the numbering because it's standardized. All mathematicians use this numbering, 1, 2, 3, 4. Also, another thing that they defined is the angle of rotation is the angle created when a line segment is rotated about its vertex, so this is the vertex, the starting point, to a terminal position. So this is an angle. The angle between, we're starting it here, and I took this, so picture it's like this, and I rotated it. And the vertex is the starting. It's the tip of this lid here, so it's this, and then you rotated it. So the angle of rotation is this angle between the arm being here and I rotating it around. Does that make sense? So just a definition. So when I say what's the angle of rotation, it means from the vertex, the angle between the two vertices. Right? So from here, and you're pretending that you're rotating it. Then people go, but wait, what if I rotated it the other way? So then they came up with a definition that if your rotation is counterclockwise, so backwards like this, so from here to here, like that, this is considered to be a positive rotation. So that's a positive rotation when we did counterclockwise. So if I said my arrow went this way. But if I have, so I'll still do the same terminal arm here. They said, okay, but what happens if I wanted to go backwards? Okay, so again, this is a definition. We still start at x, so I still want you to start here at the x line. They still like that positive x as my starting line for both of them. And a negative rotation, by definition, they said starts at my positive x and does this, under. So this is called the negative way. Because you were like, wait, how do I know which way I'm rotating? But if I go positive, they went upwards. They considered this to be up and that to be down. So if I say rotate it 50 degrees positive, that means you would rotate it, you would rotate it 50 degrees this way. If I say rotate it 50 degrees negative, you'd rotate it downwards. Is that okay? And it's just by definition, yeah. What does this have to do with anything? The triangles? Okay, what I'm going to do is I'm going to take those special triangles and I'm going to start to throw them onto a quadrant. So the next topic that we're going to do for 5354 is, look, I'm going to take those special triangles and I'm going to throw them on here. And then we're going to have negatives and positives. But that's another story for another day. So just know the definition. Positive is this way, negative is this way, and then 5354 is when I'll start the quadrants and you'll be like, oh no, we've never had triangles. Have we ever had a triangle in a quadrant? No, it's sitting in space on our page. And now I'm going to take those triangles and I'm going to throw them into a quadrant. And then we're going to do it that way, and it creates all sorts of fun stuff. All sorts of good stuff happens. So just right now is just to finish off with the definitions that we'll need next time. That's it for now. So you got to practice. You have to practice this tonight, okay? Because before we go on to the next lesson, I need you to understand this. Because we do another whole lesson with different topics tomorrow. Monday, next.